Hi everyone. Today we'll be looking at the paper explaining patterns in data with language models via interpretable autoprompting. So they want to use autoprompting, but the constraint here is that it needs to be human interpretable, and they want to use this to explain the pattern in the data. So generally, when using zero-shot prediction, you have a prompt, which could be the description of the task. You append this to the input, and then you feed this to your language model, and you get the output. So here, if the prompt is to add the inputs, you pass the inputs, which are 3 and 1, and you expect the language model to generate the output, which is 4. Whereas here in iPrompt, which is interpretable auto-prompting, they feed the data, the input and the output pairs, and they want the language model to discover the underlying relation between the input and the output. And here the language model basically predicts at the inputs is a prompt based on the inputs and outputs it's seen, right? They test their method on different data sets. And most of them have a simple description of the relationship between the input and the output. So these could be mathematical data sets such as adding, subtracting, finding Fibonacci, etc. Or it could also have like diverse language tasks, which are part of the inverse Allen NLI collection, which are like country capital. The relation between the input and the output could be country capital, antonyms, etc. They also test on sentiment classification, and they also use fMRI data. So auto prompting can be formally specified as a search problem, right? Where you have um, an input X and Y, an input and output pair, and then S is a prompt. And then you basically convert this input output pair as well as a prompt into a query which you feed to the model. Generally, S is like a template which is applied on the input and output, and you basically get a prompt, right? And this is fed into your language model. And the language model here can be considered as F, which returns the log probability of a given string, right, of a given prompt. And you choose a prompt which basically maximizes the output, right? That's what they uh, formally say auto prompting is. But here they want to add one constraint, and that is the fluency constraint, that the output which is generated needs to be fluent. So what they do is they have they generate the input and output, and initially they prompt the model with the input output and something like a prompt, right? They expect the language model to basically generate the string, the prompt. So, for example, it could be something like here, which they show. Input is 5, and output is 7 to compute the output from the input blank, right? So the language model basically generates the prompts. So here, the language model generates prompts such as combine the numbers, return the output, sum in order, compute the output. Once you get the candidates from the language model, you do a re-ranking of them based on how these prompts perform when they are used with that data set. So in the data set, you transform each example by converting it into a prompt by using these prefix strings, right? And then you compare the performance and you pick the ones where the performance is maximum. So you pick two of them, for example. And then what you do is you randomly truncate these prompts. So here, for example, combine the numbers and sum and order were picked, and you just truncate them randomly. So you have combined the and sum, and these then would be used as a prefix strings for the next round of prompting, right? So here you're prompting the model. Combine the and sum are already used as prefix strings from the previous round. Then the model generates numbers, arguments, etc., so on and so forth, right? And eventually you get the output which has like sum the numbers, which performs well on that particular data set, right? And that's how they get one prompt. And because you're using a language model to generate the output, it basically guarantees that the outputs are going to be fluent, right? And they evaluate this on the data sets which were mentioned before, and they evaluate it on a bunch of different metrics. So one is a zero shot accuracy, where they just use a prompt which they find from autoprompt. Um, uh, iPrompt, sorry. They use the prompt generated from iPrompt, and they find out the zero shot accuracy without any examples. If you just use the prompt and the input, what's the accuracy on a particular data set? And there's another method called autoprompt, which basically uses gradient descent to generate the different tokens. Um, One drawback of autoprompt is that the tokens are not really, the tokens are from the vocabulary, but the tokens together are not really semantically meaningful. And they also use average suffix, where they just use, I guess, from this method, right? Where they just let the language model complete the template, where you have, for example, to compute the output from the input, whatever the language model predicts, that would become your prompt. And they evaluate the zero shot accuracy in all three, and they find that for both the math and the ENLI datasets, zero shot accuracy is better with iPrompt, interpretable prompting. And then they look at the top prompt correctness. So the top prompt correctness basically they evaluate manually. They evaluate the prompts, and then they label whether it is correct or not by manual inspection. And obviously, iPrompt is interpretable. I'm not sure how autoprompt is evaluated manually, because this has a bunch of tokens which are not semantically very meaningful. So I'm not sure how they generate this by manual inspection. And then they also look into the mean reciprocal rank, right? Where they prompt the model with the relevant prompt, and they look at the rank where the correct output is generated, take the reciprocal of it, and compute this over the entire data set and take an average or mean of that, right? So across all these metrics, they find that iPrompt performs better than autoprompt and average suffix. I think for ANLI, sorry, average suffix is better, the last one. But everything else, they find that iPrompt performs better. And then they also have some generalization experiments where they take prompts which are generated using GPT-J as the language model, and they evaluate the same prompt without any change. They just swap the language model, and they use OPT and GPT, and they compare the performance. And what they find is uh, they find iPrompt to do well over generalization as well. Um, Here, right? They find that especially for the math data set. Whereas for the ENLI, I think for OPT, average suffix performs better, but for others, iPrompt seems to perform better. And it definitely transfers better compared to autoprompt across language models. So here are some examples of prompts which are generated using iPrompt and also autoprompt. So the human written prompt, for example, you're given a country name and you need to return the currency of a given country if that is the description of the task. iPrompt sort of generates something very close. Select currency code for a new, whereas you can see that autoprompt generates a bunch of tokens which are not really very meaningful. together, right? And there are some issues with iPrompt generated prompts, especially with some data sets. So for a data set where you have to find out if the input dish is vegetarian or not, return whether the input food dish is vegetarian. If that's the human written prompt, you can see iPrompt basically saying yes or no, right? And this is an auto prompt basically just generates a bunch of tokens. And they also do this on sentiment classification. And here there's another thing. You see that if the description for sentiment classification would be answer yes for positive and answer no for negative. I believe they fixed their label space to be yes or no, and the iProm basically I think it picks like some example where you see a fast, funny, highly enjoyable film, answer yes. Whereas autoprom still generates some random tokens. Yeah, they fix yes and no as positive and negative labels. And then they evaluate sentiment classification using prompts generated for GPT's 6 billion model. That's this. They also do a transferability analysis, and they find that iPrompt basically for certain data sets performs better than the human written prompts even. And it almost always performs better than using no prompt or auto prompt. They also have some results on fMRI data, but I'm going to skip it. You can read the paper for more details. But yeah, so they propose a method to find semantically meaningful prompts, and this also has been shown to have like strong generalization performance across different language models.